Hello, and thanks for tuning in to new insights on fiction feelings, the impact of frequent reading. My name is Anastasia Glawion, and I'll be presenting the results of an experiment conducted with Sophia Pilz and Thomas Weitin at the Literary Lab of the TU Darmstadt. The talk is organized as follows. I'll start with a general introduction, then present the experiment we were inspired by, and then go into detail about how we changed it. Then I'll say something about the participant groups and go into detail about the collected data. Finally, I'll present the results and summarize the main points we could discuss. As empirical literary scholars, we are interested in the effects that literature has on readers. One of the main foci of the Lit Lab of TU Darmstadt is to figure out ways to measure this influence. The Lit Lab encompasses two workflows. One is dedicated to corpus creation, including the digitization of corpora, as well as computer-assisted corpus analysis of literary collections, while the second one is aimed at literary reception. The second workflow includes an eye tracker, an EEG module, and different amplifiers to measure peripheral physiology, such as skin conductance response and heart rate. We are particularly passionate about combining corpus level and reception level studies of texts in general and of literature in particular. Hence, we are very interested in the study of emotion in text and emotions experienced by readers in the process of reading fiction. As soon as emotions are conceptualized as arousal and balance, they become easily operationalizable and measurable with our setup. This is why the study conducted by Sue Jacobs and others attracted our attention. Within the study, participants were presented a total of 120 passages from Harry Potter, each labeled as happy, fearful, or neutral, while their brain activity was measured in an MRI scanner. Each segment's sentiment score was also computed, and afterwards participants assessed each text passage's sentiment and gave it an immersion rating. The subsequent analysis demonstrated that reading of fear-inducing passages led to a stronger immersion rating and a more pronounced activity in the affective empathy network of the brain. The experiment had many layers to it, including a bilingual hypothesis. The texts were read in German and English, and another evaluation concentrated on the use of magic in Harry Potter novels. Here you can see an overview of related analyses. This is an example of a happy passage. The wheels of the car skimmed the sea of fluffy cloud, the sky a bright, endless blue under the blinding white sun. It was as though they had been plunged into a fabulous dream. This, thought Harry, was surely the only way to travel. You can clearly see that the passage contains lots of words with positive sentiment, such as fluffy, bright, and fabulous. The fearful passage is more grim and contains words with more negative valence, whereas in the neutral one, words with low arousal dominate. You are welcome to pause the video here and take a look at all three passages in detail. They are presented in English here, but for our experiment, we employed the German versions of the text. Our objective was to replicate the experiment, aiming at the analysis of arousal markers, pupillary response, skin conductance data, and analysis of power in the EEG signal. Our hypothesis was that the differently marked emotional stimuli would elicit different reactions. If we follow Mile and Quiken's emotional differentiation, we are interested in narrative feelings towards the characters, resonance with mood and settings of a literary text. In our experiment, 40 participants were presented the 120 text passages in a randomized manner. The participants were also presented 30 text passages with Harry Potter fanfiction, which we will not focus on today. Eye tracking data, specifically pupillary response, SCR, skin conductance response, and EEG were also recorded. After the reading task, the participants answered questions about their reading habits and provided sociodemographic data. We did not include questionnaires about immersion. However, we expected other factors to influence reading behavior and asked our 40 participants about their reading habits in 3 different ways. First, we wanted to assess the recent reading quantities of each of the participants using the reading habit questionnaire. The questionnaire collects the self-reported amount of reading over the course of the past year, divided by genres. Although it is very versatile in its assessment, it is reliable only to a certain extent. It could be prone to multiple accounts of the same book in case a piece is considered, for example, both a horror book and a parody. Also, it is a self-reported measure, therefore social desirability plays a role. Finally, during the experiment, some participants asked how they could account for phases in reading habits. What if they read a particular kind of books repeatedly over the course of several weeks, but then stopped? We aimed at groups similar in size and divided the participants into frequent readers, average readers, and non-frequent readers. At some point, we were speculating whether reading of fiction would particularly strongly affect the reactions to narrative, and filtered out the non-fiction reading habits. But we found that nonfiction was spread proportionally and its exclusion did not change the constitutions of the groups at all. We also asked our subjects to fill out the author recognition test in German and wanted to find out the overall knowledge of the literary system. Some studies also interpret the author recognition test as lifelong exposure to literature. The groups we divided the participants into were literature buffs, literature rookies, and middle ground subjects. As expected, there was some overlap between the groups, but it was not cohesive. We measured the 2 sets with Kendall's rank correlation coefficient, whereby the relationship between the 2 data sets was weak. The third division we considered was the inclusion of fandom knowledge. Our questionnaire contained 2 questions about the knowledge of Harry Potter fandom, asking whether participants had seen none, some, or all of the movies, and whether they had read none, some, all of the books, or all of the books plus additional material such as fan fiction. Because fan fiction and fan cultures are a general interest of ours, we expected Harry Potter fans to have an even stronger reaction to the presented stimuli. We coded the responses and added them up into a fandom score, of which the maximum was 5 and stood for participants who have seen all of the movies and read all of the books and some additional material. As we noticed throughout our Harry Potter fanfiction research, the fans often consider both the movies and the texts to be canon and do not follow a strict division between the 2. A fandom score of 0 meant that the participant did not read any of the books and did not see any of the movies. Overall, we had 17 fans with a score of 4 or 5, 13 middle ground subjects with a fandom score of 2 or 3, and 10 non-fans with a fandom score of 0 or 1. The rank correlation between the fandom score and the other 2 groups was also weak. The skin conductance data was recorded with Brain Vision Recorder and exported with minimal pre-processing. The data was then processed in LeaderLab, a MATLAB-based software for skin conductance response, whereby a continuous decomposition analysis was performed. As a result, LeaderLab outputs a table with different characteristics during the response window, which was set to 3 to 15 seconds after stimulus onset. We were particularly interested in the number of peaks during a passage, as well as the sum of amplitudes, the overall skin conductance response during a passage, and the global mean of the response. LeaderLab also outputs data on the tonic response. The average values for each participant were calculated for all trials and for all trials per emotion category, happy, fearful, or neutral. The pupil data was extracted from SR Research's data viewer software with a fixation-based report. To ensure that artifacts connected to blinks were filtered out, Those values were deleted which differed by more than 10% in size in comparison to the next fixation. For better comparability, the pupil size data was normalized by dividing the pupil size through the maximum pupil size of each participant. The average values for each participant were also calculated for all trials and for all trials per emotion category. The EEG data was collected with brain vision recorder and analyzed in brain vision analyzer. Blinks were removed using an ocular correction algorithm, and trials with artifacts were not considered in the analyses. The data was segmented into happy, fearful, and neutral segments, and they were then divided into 3-second intervals and averaged out. Finally, an fast Fourier transformation was performed, and both over all of the groups and each of the category divided of the reading habits. The questionnaire data was collected using Qualtrics. The reading habit questionnaire was kindly provided by Monique Kuipers, and we used the German version of the author recognition test by Grolich and colleagues. During data processing of the skin conductance response and the pupillometry data, we paid special attention to whether the data fulfilled the requirements of the ANOVA test. It turned out that the pupil size and the data for the number of peaks were normally distributed, but most of the skin conductance response data were not. The normally distributed data was examined with a standard ANOVA, while the Kruskal-Wallis test was performed for the non-normally distributed values. After the calculations with the analysis of variance and the Kruskal-Wallis test, an evaluation of the effects was carried out with epsilon square, which showed that the significant results also demonstrated high effects, and most results that were approaching significance demonstrated medium effects. Here is a table of p-values from the Kruskal-Wallis test. I would like to focus here on the values in bold. These are the values that the epsilon square test has considered to have a medium effect. In case the value is underlined, the effect was considered strong. We can see that the groups generated by the author recognition test demonstrated significant differences in their means in most of the values. What we also see is that in one case, the groups according to fandom knowledge are motivating subsets with a significant difference in means. This happens in the case of the overall mean of the happy stimuli. The significant difference across groups generated by performance in the author recognition test is also visible in the normally distributed data. Another result we see is the fact that pupil size had medium effects in all three groups and is the only value that performed better when joint effects were analyzed. Specifically, the results of the author recognition test and the reading frequency together had influence on pupil size. The significant effects usually manifest themselves like this. The behavior of the literature buffs is different in comparison to that of middle ground subjects and literature rookies, like in this graph. The mean number of skin conductance reactions shows a significant difference between buffs on the one hand and rookies and middle ground subjects on the other. Here it seems that knowing the literary field correlates with more frequent reactions to literary texts. As expected, while showing the most peaks, the sum of the peaks amplitudes is also the highest for buffs. Interestingly, the difference between rookies and middle ground subjects is more pronounced here. While the number of peaks for rookies and middle ground subjects stays the same as we have seen in the previous picture, the sum of amplitudes is higher for rookies in comparison to middle grounders. Perhaps rookies are reacting as often as middle ground subjects do, but they have stronger reactions each time. Maybe they are more nervous in an experiment that involves reading. But we originally set out to find differences in reactions to stimuli with different emotions, whereby skin conductance response and pupillary response were considered indicators of arousal. The values in each category were compared to their emotional subsets via a t-test, and without the group division, there was no significant difference between the average and the average of emotional stimuli across all of the values. If a division by performance on the author recognition test is employed, we can see that literature buffs demonstrated significantly larger responses in most of the values. There was a higher number of peaks, the phasic driver was stronger, and so on. Among the data on buffs, the responses to happy stimuli were the highest, and responses to neutral ones were almost always the lowest. The rookies, on the other hand, mostly demonstrated minimal values for happy stimuli. Most often showed highest values with neutral ones. None of these values differed significantly from the mean. The middle ground users didn't show a clear pattern. It was sometimes the lowest values were to fearful stimuli, and there was no cohesive pattern. An FFT analysis of the EEG results demonstrated higher activity of more experienced readers in the theta and alpha bands, both for groups generated by the author recognition test and those generated by reading frequency, especially in happy stimuli. You can see it in this visualization, where the blue line, which represents more experienced users, is located much higher than the red line and the colorful data that represent average readers and non-frequent readers, respectively. An activity like that can be interpreted as both boredom or mind-wandering, suggesting that buffs could be more prone to imagining what they are reading and are perhaps engaging in mind-wandering. We are very aware of several drawbacks in our study. For example, it has quite low statistical power, and the participants are all university students, which means that literature rookies still have a fair amount of reading in their pocket. Maybe this is why the data doesn't demonstrate a strong difference between rookies and middle ground subjects. Still, there are several results in our experiment that we would like to discuss. The data demonstrates that knowledge of the literary system influences physical reactions to reading to a significant extent. Readers with more exposure to fiction react stronger to literary works, and they reflect the arousal metrics that a text contains. Stronger reactions to emotional content and weaker reactions to neutral passages. Readers with less knowledge of the literary field seem to react strongly even to neutral stimuli, perhaps expecting an emotional stimulus and being anxious upon not receiving it. According to these results, knowing about literature accounts for a different type of reaction. Why are literature buffs behaving differently? Does the stronger reaction mean that they empathize more, or maybe they are just more excited to read? The significance of the author recognition test has been observed before, for example, in the famous study by Kidd and Castano, as well as in the larger, statistically more powerful follow-up study by Panero and colleagues. But a more detailed explanation of this effect is still to be formulated. Despite our expectations, there was no significant influence of fandom knowledge, although the overall mean of skin conductance in happy stimuli was higher for fans. Perhaps a combination of nostalgia and narrative feeling accounts for that. Finally, recent reading activity obtained from the Reading Habit Questionnaire has almost no influence on physiological reactions, only as an additional factor when considering pupil size. It seems that we are left with one more unanswered question. Does exposure train the emotional response, or are perceptive people just more drawn to literature? This is a good object for possible future experiments and a good discussion. Thank you very much. I'm looking forward to talk about our experiment.